Hello, beloved students, how are you? So, after successfully completion of the alkane, today we will start the alkene. So, first question, what is alkene? Alkenes means the such hydrocarbon. Hopefully, you know about the hydrocarbon. You have studied it on the alkane part. Hydrocarbons means the compound composition with the carbon and hydrogen. So, alkenes are the such kinds of hydrocarbon which are composed by the carbon and hydrogen and must be there present at least one carbon-carbon double bond. That means the alkenes are the such compounds which contains at least one carbon-carbon double bonds. What are the example? Like the ethylene, like the 1-propylene, etc. So next question is, what is the basic difference between the alkane and alkene? Alkenes are the much more reactive than the alkane because here presence of the one double bond, and it is also known as the olefin. Olefin, the word comes from the Latin word oleum and ficare. Oleum means the oil and ficare means the to make. That means from the alkene we can make the oil. Okay. So it is the introduction part of the alkene, and basically alkenes are the prepared by the one carbon-carbon double bond, at least one carbon-carbon double bond, and maybe the 2 or 3 also be present in the one alkene. In alkene, there are the basically general formula is the CnH2n. What was the general formula of the alkane? CnH2n plus 2. But in case of the alkene, the general formula of the alkene is the CnH2n. That means if we consider N as the 2, then the structure of the alkene will be C2H4. That means the ethylene. Okay. Next, remember what is the structure of an alkene? See, hopefully you can see this picture number 3. It is the structure of the ethylene. Okay. It is one alkene. So what is the bond length of the carbon hydrogen? What is the bond angle? That is the very much important. Remember, in case of the alkene, it is the sp2 hybridization. It is totally the sp2 hybridization, and the bond angle between the carbon hydrogen and carbon carbon both consist the 120 degree, and the bond length between the carbon carbon is the 1.34 angstrom, and the bond length between the carbon and hydrogen is the 1.09 angstrom. And these two carbon-carbon bond between the two carbon-carbon double bond, one carbon-carbon double bond is the sigma bond and another is the pi bond. Hopefully you remember, I have already told you that alkenes are the much more reactive than alkane. Why? Because this presence of the pi bond. That means pi bond consists of the pi electrons. Due to that reasons, they are much more reactive than the alkanes. Okay. Next one. What is the example? Already I have told you. Ethylene, propylene. There are lots of alkenes are present. Okay. Next one. The nomenclature. Same as the alkane. First one is the common system. Second one is the IUPAC system. What is the common system? Common system is the, see here, that is the alpha butylene and the beta butylene. Okay, it is the common name. And in case of the IUPAC name, hopefully you have studied already the IUPAC name. Same like the IUPAC name. That means the 1-butane. In case of the in case of the alpha butylene, it is named as the 1-butane, and in case of the beta butylene, it is named as the 2-butane. Okay, 1-butane and 2-butane. It is the IUPAC name. Next one is the isomerism. Isomerism, there are the basically 3 kinds of isomerism occurs in case of the alkene. Number 1, remember this point. Number 1 is the position isomer. What is the position isomer? It has been occurred by differentiate the position. That means in case of the 1-butene and 2-butene, that means the alpha butylene and beta butylene. They are the one example of the isomerism, that means the position isomerism. Second one is the branch chain isomer. What is the branch chain isomer? Remember, in case of the branch chain isomer, first one, if you consider the structure of the 1-butene, it is the structure of the 1-butene. If you structure the 1-butene, in case of the branch chain isomer, it has been considered as a 2-methyl propane. It is one example of the branch chain isomerism. And third one is the totally geometrical isomerism. Geometrical isomerism means what? Hopefully you have studied in the high secondary cis and trans position. What is the basic difference between the cis and trans position? In case of the cis position, the particular functional group should be present in the same side of the carbon atom. But in case of the trans isomer, it has been present to another side of the carbon atom. If the to another side has been present the particular functional group, that it is called the trans isomer. And if the particular isomer is present on the single side, then it is called the cis isomer. That means here, see, first one it is the cis 2-butene and second one is the trans 2-butene. See, in case of the trans 2-butene, the methyl group you must show there. The trans 2-butene, in case of the trans 2-butene, the methyl group is present on the two side of the carbon atom. But in case of the cis isomer, cis 2-butene, there the methyl group is the present in the same side. Okay. So this is the geometrical isomerism. Now we will start the method of the preparation, and I will describe it on my next video. Goodbye.